The Milky Way is a tremendous structure in space containing billions of stars and trillions of planets. In their turn, these objects are surrounded by gigantic clouds of interstellar dust and scorching hot gas streams. All these components make up the bizarre and fascinating picture called galaxy. And today, we invite you on an exciting journey across it. We're determined to discover traces of life on remote exoplanets, so we cast our gaze far beyond the boundaries of the solar system and into the great abyss of space. But actually, just several hundred years ago, a unique world was detected comparatively close to us. There are clouds in its atmosphere, it rains there, and on its surface, great rivers flow into lakes and seas. Still, the conditions on this fascinating celestial body are lethal, with the surface bound by incredible cold. So what is really happening on Titan? Titan is located about 10 astronomical units from the Sun and is outside the habitable zone of our star. It is Saturn's largest satellite, and its orbit lies well outside the Great Rings, at a distance of about 1,200,000 kilometers from the center of the planet. The trajectory of the celestial body is close to circular, and a complete orbit around the gas giant takes a little less than 16 Earth days. Titan's diameter is 5,152 kilometers, which is 5.6% larger than that of Mercury. At the same time, the mass of the celestial body is relatively small at only 1.35 times 10 to the power of 23 kilograms, which is about 40% of Mercury's. Calculations show that the satellite's average density is about 3 times less than that of the Earth, which means it has a completely different chemical composition. According to contemporary concepts, Titan has a massive core at its center, about 3,400 kilometers in diameter and made up of various silicon compounds. It is surrounded by a thick layer of densely packed ice, which is at the bottom of a cold liquid ocean hundreds of kilometers deep. The ocean, in its turn, contains large amounts of dissolved ammonia, methane and various caustic salts, so that its freezing point is markedly lower than that of ordinary water. For this reason, Titan's subsurface ocean remains liquid even in sub-zero temperatures. It is bound by a thick crust around 100 kilometers thick, consisting of a mixture of water ice and methane hydrate. The tidal forces of the nearby Saturn are continuously deforming it, causing massive rifts and fractures. This causes large cryovolcanoes to form, ejecting great quantities of methane, ammonia and water onto the surface of the celestial body. Methane plays about the same role in Titan's atmosphere as water vapor on Earth. The fact is that the average surface temperature of the satellite is only about 94 Kelvin or 179 degrees Celsius below zero, which is slightly below its boiling point. Natural variations in this parameter cause hydrocarbon vapors to condense and precipitate, forming methane seas, lakes and rivers. Titan's atmosphere is composed mainly of hydrogen, which makes up about 98.4% of its volume, while methane accounts for about 1.6%. Due to its extremely low temperature, the satellite's atmosphere remains condensed near its surface, and the ring of the mountains surrounding it is less than 500 meters high. Most of the surface of the celestial body is permanently obscured from our eyes by multi-layered clouds and an orange-yellow tholin haze. This unique weather phenomenon is a fog formed by tiny droplets of liquid methane and dissolved organic matter, which gives Titan its characteristic hue. This haze pervades Titan's surface, absorbing and scattering visible light but transmitting infrared light. This peculiarity leads to an unusual anti-greenhouse effect, which cools the satellite's surface by roughly another 10 degrees. This effect makes Titan difficult to explore, but thanks to the Cassini's orbiter's infrared cameras, Titan was in parts mapped out earlier this century. Of course, it is not as accurate as we would prefer, but even this much is enough to outline the most striking features of the celestial body's surface. The face of Saturn's largest moon is full of contrasting spots. Some of these reflect most of the light that falls on them, while others are relatively dark in color. One such area is slightly south of the equator and is called Aztlan. One of Titan's highest mountains, Mount Doom or Doom Mons, is located here, towering about 1.5 kilometers above the surrounding plains. The whole mountain reaches up to 60 kilometers in diameter. Its summits are craters, and its slopes have relatively fresh traces of turbulent flows. This may suggest that Doom Mons is an active cryovolcano. To the northeast from it is Titan's deepest depression, called Sotra-Patra. It is a giant depression about 30 kilometers long, the bottom of which is located about 2 kilometers below the adjacent plains. It is thought to be the mouth of a huge cryovolcano and is part of a single tectonic structure along with Doom Mons located close by. To the north of Doom Mons, there stretches the immense Mahini Fluctus, a vast area covered by Doom Mons' ejections. The area extends for about 180 kilometers and varies in width from 15 kilometers in the south to 60 kilometers in the north, where torrents of frozen material alternate with expansive fields of sand dunes consisting of a mixture of frozen methane and water ice. Our flight will continue over the dark area of Fensel. The largest impact crater of the celestial body, Minerva, is located in its northwestern part. It reaches 440 kilometers in diameter, which is about 3 times larger than any other crater on Titan. The depression is about 200 meters deep, and the ring of the mountains surrounding it is less than 500 meters high. The fact is that according to studies, Minerva is not only the largest, but also the oldest extant crater on Titan. Different estimates put the age of the crater at between 300 million and 1.2 billion years. Erosion and tectonic processes have severely damaged the crater, and it is only thanks to its sheer size that it is still visible. Minerva has a well-defined internal structure. At its center there is a small flat plain, surrounded by a ring of hills. This region, with a total diameter of about 200 kilometers, is rather light and clearly visible from space. It is surrounded by a so-called moat, a stretch of dark plains about 50 kilometers wide. This is followed by a ring of low mountains that form the outer boundary of the crater. Our flight next takes us to the south. Here is one of Titan's most impressive and mysterious landmarks, Hautei Arcus. This is a unique formation in the solar system and is a bright, arc-shaped region about 600 kilometers long. Radar data from Cassini shows that Hautei Arcus is a natural boundary between the Rocky Mountains in the northeast and a wide valley in the northwest. It is also noteworthy that some parts of this area change color from time to time. This phenomenon is thought to be linked to the eruptions of cryovolcanoes, whose emissions cover the surface of the satellite in a thin layer and then flow into a nearby valley or evaporate into the atmosphere. From space, one can clearly see light channels similar to riverbeds running from the mountains of the Hautei Regio to the northwest. This is where Xanadu is located, which is a vast lowland area with highly rugged terrain. Its northwest boundary is formed by Mithrim Montes, which are 3 parallel ridges stretching for about 150 kilometers, with an average height of 1.9 kilometers. Among the peaks of the southern range is the highest peak on Titan, reaching 3,337 meters. Standing on top of it and looking west, you can see a vast dark plain stretching several hundred kilometers in front of you. It is called Shangri-La, and it is thought that this whole area used to be flooded with liquid methane. It is assumed that it may have persisted beneath the topsoil, similar to the Earth's underground water. Most of this region is below average elevation and has a and whenever some of them are solved, they add to our knowledge about the universe around us. Are we to solve all its mysteries someday? Time will show.